It looks alright. Maybe it was. ومرة ثانية سمعت يسوع بيقول حاجات ملهاش أي معنى بالنسبة لي.
This project is sponsored by PCBWay. From concept to production, PCBWay provide cutting-edge electronic design solutions for global innovators including hardware design, software development, mechanical design, product testing, and certification. PCBWay engineering team consists of experienced engineers in electronics, embedded systems, and product development. They successfully delivered hundreds of projects across industries such as medical devices, industrial automation, consumer electronics, smart home, and IoT. Hello, software-defined radio is a radio communication system where many of the key electronic components of a classic radio receiver, such as filters, amplifiers, and detectors, are replaced by software that runs on a computer or mobile device. In several previous videos, I have presented various ways to make software-defined radios, from the simplest with a single vacuum tube to SDR with a Raspberry Pi Pico and 2 displays. Basically, they are all made in a classic well-known ways. This time I will present you a very unusual and simple way to make an SDR radio with a chip that is not for this purpose at all. Namely, the project uses the MCP2036 integrated circuit from Microchip, which was originally intended as a front-end for inductive touch systems. The idea was promoted long ago in the journal Funk Amateur by Dr. Martin Osman and entitled Circuit for Inductive Sensors as a Receiver Front End. While its primary purpose is measuring tiny changes in coil inductance for touch interfaces, its internal architecture containing a high-frequency driver, multiplexer, mixer, and synchronous detector allows it to function as a low-frequency RF front-end. So, with this chip, an extremely simple direct conversion receiver can be made according to the given characteristic with a possible upper frequency limit of approximately 10 MHz, but as you will see in this project, it also functions quite solidly on the 90-meter broadcast band IA at frequencies up to 15 MHz. We only need a few passive components and external oscillator to select the desired frequency. For this purpose, I use my VFO with a 1.28-inch circular display, the construction of which is described in one of my previous videos. Always the output signal can be fed directly to an audio amplifier, thus obtaining a standalone direct conversion receiver. However, in this described way, I use this circuit as a front end of an SDR radio, and in this way with PC software can be performed the modulation of many different types of analog and digital radio signals. Here is what the finished device looks like. I mistakenly got an MCP2036 chip in a SOIC package. Otherwise, it is much simpler to make it with a chip in a DIB package. Here is the antenna connector, VFO signal input connector, and the audio output. The other device is variable frequency oscillator. Now let's see how this SDR radio works in real conditions. For reception, I will use my long wire antenna mounted on the roof of the house.
По его указу перед парадным подъездом главного дворца был спроектирован большой фонтан с кожухом раковины. По периметру раковины украшали бронзовые скульптуры 12-15 зодиакальных животных. Они были не только символом 12-летнего цикла, но и
Delta, Rescue 0, Hotel Green, 9 Alpha 0, Hotel Green, price line, Hotel Radio Sierra. Roger, Roger, front Alpha Radio, for anything. Yeah, good contact, front Alpha 0, Hotel Green.
arheologie și de arta și prezența dacilor în Roma au fost extraordinare.
This is DRMC now. Digital Radio Mondial.
Après un voyage d'environ 400 jours, la chaîne de suivant.
دي بنتك تعيش انت. ومرة تانية سمعت يسوع بيقول حاجات ملهاش أي معنى بالنسبة لي.
ሰላም አለን ይላል። እንግዲህ መጽደቅን ተከትሎ የሚመጣ እንደሆነ ከዚህ እንረዳለን። ከመታረቅ ጋር ተቀራራቢ ትርጓሜ ያላቸው ደግሞ ሌሎች
And finally, a short conclusion. In this project, I demonstrate an extremely simple direct conversion SDR receiver based on the Microchip MCP2036 integrated circuit. With only a handful of passive components and an external VFO, this unusual circuit becomes a surprisingly capable SDR front-end covering frequencies up to approximately 15 MHz. The receiver is tested on several high-frequency amateur and shortwave broadcast bands using SDR software running on a PC. Despite the simplicity of the circuit, the results are impressive and make this a fascinating experiment for every radio electronics enthusiast.